Today we're going to be doing simulation example in chapter 12, number 2 specifically. Let's get to the Ask My Professor Instructor version of that question. Right, while we're waiting for it to load, I want to point out that, like, it seems to be the style in all the simulation questions. While they show you how you could do the simulation, they don't expect you to do it. They simply want you to process the numbers that come from the simulation. So in this particular question, we're trying to predict market share as a percentage. And market share depends on 3 factors. What percentage of the customers will try the brand? What percentage will purchase it? And see here, preliminary data suggests the brand will attract heavier than average buyers to purchase 15% more than the average buyer. We have to boost our estimate by 15%. Okay, now the problem with these, if these were just fixed numbers, we just multiply them or we'll do some kind of processing, some kind of an equation. But they're random numbers, at least one of them is random. And in particular, the percentage of new purchasers who try the brand is uncertain. It's normally distributed with a mean of 30%, meaning about 30% of the time. But it also has some deviations. Some are at 33, some are at 36, some are at 27 or 28 or 25. So we do a Monte Carlo simulation, and the book produces 50 trials, which is no big deal. They want you to get the average percentage, etc. We'll get to that later. But the first step is to fill in these numbers, which I've already filled in. So the first, given the 3 different terms, T, R, and B, we multiply them. So T times R times B, which in algebraic notation is the multiplication of the product. The value of T is randomly generated using an Excel formula. This is the formula that you would use if you were creating this on your own. In order to create random numbers which have a mean value of 0.3, which corresponds to 30%, and a standard deviation of 3%, which is 0.03 in decimals, you put in this other bit over here, random, which means, anyway, some technicality, which I'm not going to get into, that generates random numbers, such as the numbers that, well, then the other variables are, so you generate a random number and multiply it by 1.15, because again, and then multiply it by 0.65, because 65%, where's that 65%, will purchase it. So to get the total market share, you multiply these 3 numbers. Now, once you have these numbers, that's the hard part, to come up with this algorithm. But once you have these numbers, we're going to open them in StatCrunch, which we can't do because I have to log into MyLab. So I'll do Pearson. Yep. Try this. And paste login. Login page. Oh, I'm sorry for this. Educator. Okay, it's already there. Be the wrong password, I suspect. No, looks like it's the right password. And again, you could answer the question about the mean and the standard deviation and the average, etc. But while we're waiting, if you multiply the three numbers that were given, the averages, let's do it when we see it there. Okay. Now we go back to numbers, the StatCrunch. And okay, so let's go through this. So these are the numbers. If you multiply, we're multiplying the T and the R and the B. The T has an average of 30%. This one is 1.15 and this is 0.65. So if you multiply 0.3 times 1.15 times 0.65, you get 22.224, which is 22.4%. So you'd expect the average is 22.4, and you and in fact, if you did enough samples, you would get 22.4. But with the advantage of the simulation, it also gives us a sense of the range. It gives like that they're all not going to be 22.4. You can see these numbers here again. Here's our random numbers. They vary. So this is very valuable information when you want to plan a minimum value, the median, the maximum, the range, etc. So to get the basic statistics, we go to stats, summary stats, columns, pick var1. At this point, you simply say compute, and you get a whole bunch of numbers, such as the mean, which we said theoretically should be 22.4, but in this group of 50 was only 22.03. We had 5,500 or 5,000, it'll be very close to 22.4. So put in 22.0, see if that's right. Yes. And the standard deviation, according to these numbers here, is 1.93. So it's 1.93. 19.3, I believe, percentage, which is a pretty large. Let's double check that. Standard deviation, move this over by, oh, no, these numbers are already in percentages, right? 22.03. So this number here is 1.93. Sorry about that. That I'm pretty sure is right. The minimum valuable piece of information is 18.55. And we're obviously on a roll here. Maximum is at 26.05. And believe it or not, I believe we're done. Okay, I hope that helped. And again, think about the fact that we have to multiply these three numbers.